Hi everybody, so in another video we looked at the bulk composition here at 20% anorthite. What if we take something that's over on the other side of the liquidus? Let's take something that is, I don't know, 90% anorthite. So we'll move our bulk composition here. So this is a very different kind of rock. We had a rock earlier that was mostly diopside, 80%, just had a little bit of plagioclase feldspar. Now we have something that's 90% plagioclase and just 10% pyroxene or diopside. So what will happen is very similar to what happened in the first case. If we take this rock and begin heating it, it really doesn't matter what the proportions of plagioclase feldspar, anorthite, and diopside pyroxene are. That rock will still begin melting at 1274 degrees. So we'll heat it up, it'll hit this point, and then the first liquid will be back here. Notice this line hasn't changed since we looked at the other video. So here it is. The first liquid is sitting at the eutectic. The only difference here is that this bulk composition is hitting the anorthite plus liquidus surface. The only way we can get to this point here, we're going to take this rock and we're going to melt it from very cold to very hot. The only way you can get to this point here is to go up this curve instead of this one here. And the only way we can go up this curve, anorthite plus liquid, is if we get rid of all the diopside. So we'll still sit here at 1274, creating liquid of this composition, but we'll do so now until diopside runs out. So in the previous example, we ran out of anorthite first. This time we're going to run out of diopside first. Once all the diopside is gone, as we continue heating, we'll start heating up the liquid, and the liquid will migrate up this curve. It's migrating up this curve because now anorthite is the only mineral left, so we're going to drive the liquid in this direction towards anorthite, and adding heat now will allow the system to increase its temperature. The sum of this vector and that vector is to go up the liquidus surface. And we'll keep slowly melting out anorthite, more and more anorthite, until we get to this point here. And at that temperature, the last little bit of anorthite crystals are gone, and that temperature is about 1545 degrees. I think that's about the 1550 mark there. I'm moving the wrong thing, so that's about 1550 there, so we're just a little bit below 1550. So you can call it 1545 or something like that. So that's when the last little bit of anorthite crystals would be gone. Any further heating and we have no crystals left, we're back to the bulk composition, but now that bulk composition is entirely liquid instead of entirely solid. And so further heating just makes that liquid hotter.